Math 1108, Section 8.5, Division with Radicals and Rationalizing Denominators, Part 2. We'll start up again from where we left off. On this one, we have a different sort of situation here. 3 divided by 5 minus the square root of 3. There's a square root in the denominator, so we have to rationalize the denominator. The way that we're going to get rid of the radical in this denominator, we're going to multiply by 1 as usual, but the form one takes this time will involve what we call the conjugate of this denominator. This denominator is 5 minus the square root of 3. The conjugate of that is 5 plus the square root of 3. So we're going to multiply the numerator by 5 plus the square root of 3 and the denominator by 5 plus the square root of 3. We're just multiplying by 1, so we're not changing the value of the number, we're just changing its form. In the numerator, we'll multiply 3 times the quantity, 5 plus the square root of 3, and we get 15 plus 3 times the square root of 3. In the denominator, we multiply those two expressions the same way that we would multiply binomials. 5 times 5 is 25. And then we're going to add 5 times the square root of 3. And then we're going to subtract the square root of 3 times 5, which is minus 5 times the square root of 3. And then finally, we're going to subtract the square root of 3 times the square root of 3, which is minus the square root of 9. And then we'll do some simplifying. In the numerator, we have 15 plus 3 times the square root of 3. And in the denominator, notice that in the middle, 5 times the square root of 3 minus 5 times the square root of 3, those combine to make 0. And so we have 25 minus 3 because the square root of 9 is 3. And then finally, we can write 15 plus 3 times the square root of 3 in the numerator, and 25 minus 3 is 22 in the denominator. So we succeeded in making the denominator a rational number. There is no longer a square root in the denominator. Okay, the next one involves the same sort of maneuver. This time we have a denominator that is 8 plus the square root of 7. And so we need to get rid of the square root in the denominator. In other words, we need to rationalize the denominator. So we're going to do the same sort of thing we did in the previous example. We're going to multiply by 1 in the form 8 minus the square root of 7 over 8 minus the square root of 7. 8 minus the square root of 7 is the conjugate of 8 plus the square root of 7. Okay, so we'll multiply in the numerator. 29 times 8. Well, let's see. That's 232, I think. And then minus 29 times the square root of 7. And in the denominator, 8 times 8 is 64. And then we're going to subtract 8 times the square root of 7. And then we're going to add the square root of 7 times 8, but that's just plus 8 times the square root of 7. And then we're going to subtract the square root of 7 times the square root of 7, which is, we're going to subtract the square root of 49. Okay, so the numerator stays the way it is, 232 minus 29 times the square root of 7. And we have in the denominator, notice that the two middle terms combine to make 0 again, minus 8 times the square root of 7 plus 8 times the square root of 7. Those add up to 0, and then we're left with 64 minus the square root of 49 is 7. So the final step in the numerator 232 minus 29 times the square root of 7, and then divided by 57, because 64 minus 7 is 57. Okay, and the next one, the same sort of idea on this one. This time we have in the denominator the square root of 5 minus the square root of 3. Okay, so we multiply by 1, this time in the form the square root of 5 plus the square root of 3 over the square root of 5 plus the square root of 3. And then we multiply the two numerators, 2 times the quantity square root of 5 plus the square root of 3. We get 2 times the square root of 5 plus 2 times the square root of 3. And in the denominator, the square root of 5 times the square root of 5 is the square root of 25. And then we have plus the square root of 5 times the square root of 3, which is plus the square root of 15. And then we have minus the square root of 3 times the square root of 5, which is minus the square root of 15. And then finally we have minus the square root of 3 times the square root of 3, which is minus the square root of 9. Okay, in the numerator we have 2 times the square root of 5 plus 2 times the square root of 3. And in the denominator, the square root of 25 is 5. And then the square root of 15 minus the square root of 15, those add up to 0. And minus the square root of 9 is minus the square root of 3. Okay, since I'm running out of room, I'm going to just note that in the denominator 5 minus 3 is 2. And 2 is a common factor of every term in the numerator. So if I divide every term by 2, the final answer will just be the square root of 5 plus the square root of 3. Okay, the next example, 4 divided by 3 plus the square root of x. Okay, well, the same sort of thing that we did on the previous 3 examples. We're going to multiply by 1. We'll multiply the numerator and the denominator by the conjugate of 3 plus the square root of x. In other words, we're going to multiply the numerator by 3 minus the square root of x, and we're going to multiply the denominator by 3 minus the square root of x. So we're just multiplying by 1 in this form, and then in the numerator multiply 4 times the quantity 3 minus the square root of x. 4 times 3 is 12, and then minus 4 times the square root of x. And in the denominator, 3 times 3 is 9, and then minus 3 times the square root of x, and then plus the square root of x times 3, which is plus 3 times the square root of x. And then we're going to minus the square root of x times the square root of x, which is the square root of x squared. And then we have a little bit of more simplifying to do. In the numerator, we just have 12 minus 4 times the square root of x. And in the denominator, 9. The two middle terms add up to 0 again, and then minus the square root of x squared. The square root of x squared is x, so we just have minus x, 9 minus x in the denominator. And there's nothing more we can do to simplify further. That's the final result on that one. Okay, on the next one, x plus y divided by the square root of x minus the square root of y. Well, we need to rationalize the denominator because we don't want the square roots there. So once again, we multiply the numerator and denominator by the conjugate of this denominator. So the conjugate of the square root of x minus the square root of y is the square root of x plus the square root of y. And we multiply the numerator and the denominator by that. In other words, we're just multiplying by 1. Okay, so in the numerator, we have to multiply x plus y times the square root of x plus the square root of y. So x times the square root of x is x times the square root of x. And then we have to add that to the square root of x times the square root of y, x times the square root of y. And then we multiply y times the square root of x, so that's plus y times the square root of x, and then plus y times the square root of y. Notice that none of those terms in the numerator can be combined because they are not like terms. Okay, then in the denominator, well, let's do a little bit of shortcutting here. We multiply the square root of x times the square root of x, which is the square root of x squared, and that's just x. Okay, then the square root of x times the square root of y is plus the square root of xy, but then we're going to subtract the same term because the square root of y times the square root of x is also the square root of xy. So in one case we have plus the square root of xy, and then we have minus the square root of xy, so they cancel each other out. And then the final term, we're going to subtract the square root of y times the square root of y, but the square root of y times the square root of y is just the square root of y squared, which is y, so we're just going to subtract y. Okay, and so this is the simplified result. Okay, on the next one, maybe we won't have to simplify in such draconian manner. This has a denominator 9 plus the square root of x. So we're going to rationalize the denominator by multiplying by 1 in the form 9 minus the square root of x divided by 9 minus the square root of x. Okay, so we multiply in the numerator. 9 times 9 is 81, and then minus 9 times the square root of x, and then minus the square root of x times 9, which is minus 9 times the square root of x again, and then negative square root of x times negative square root of x. A negative times a negative is positive, and the square root of x times the square root of x is the square root of x squared. And then in the denominator, 9 times 9 is 81, and then minus the 9 times the square root of x, and then plus the square root of x times 9, which is just plus 9 times the square root of x, and then minus the square root of x times the square root of x is minus the square root of x squared. And then in the next step, we can write the simplified form. In the numerator, we have 81. The two middle terms combined to give us minus 18 times the square root of x. The two middle terms are like terms, but both of them have a negative coefficient, so they don't cancel each other out this way. And then the square root of x squared is just x, so we get plus x. And then in the denominator, this time the two middle terms add up to 0, and we're just left with 81 minus x because the square root of x squared is x. Okay, we'll start this next one. 3 divided by the fourth root of 5. So we have to rationalize the denominator. So we ask, what would I have to multiply by 5 to get a perfect fourth power? Well, since 5 is 5 to the first, I would have to multiply 5 times 5 to the third to get 5 to the fourth. 5 to the third is 125. So I would have to multiply the numerator by the fourth root of 125 and the denominator by the fourth root of 125. And then I'll get 3 times the fourth root of 125. And in the denominator, the fourth root of 5 times the fourth root of 125 will simplify to 5.